Friends, let me quickly do a derivation on a gas turbine analysis. This derivation is for obtaining an expression for optimum pressure ratio in order to get maximum work. So what I mean by this, let me first explain you. We are doing a topic of gas turbine analysis, gas turbine power plant analysis, and we are going to do an expression for the optimum pressure ratio. Optimum in the sense that it gives you, at this pressure ratio, one would expect the power plant to produce the maximum work. Okay, so the expression which I have in mind is this: T max upon T min raised to gamma upon 2 into gamma minus 1. So this is the expression I'm going to derive. Okay, and this derivation is pretty simple. We need to use a bit of calculus for this. Let me first explain you what is the optimum pressure ratio and what optimum means to me here. We know that in a gas turbine power plant, so if we take a gas turbine power plant, this is a compressor, this is a combustion chamber, we have a gas turbine. So in the gas turbine power plant, because some of the work is consumed by the compressor, the net output of a gas turbine power plant is the turbine work minus the compressor work, right? If I call the entry condition as 1, the compression is 1 to 2, the heat addition is 2 to 3, and the expansion is 3 to 4, then the representation of this cycle on a temperature entropy diagram is as follows. So we know that it is the Breton cycle which I am talking about. Okay, and its representation is pretty simple. We have a compression from 1 to 2, which is isentropic. Then there is a heat addition, which is at constant pressure. Then there is an expansion, which is again isentropic. And then there is a heat rejection, which is again at constant pressure. So this is pretty simple representation of the gas turbine power plant on a Breton cycle. But that is not to be discussed right now. This is the heat rejection. This is a closed cycle now which I have drawn. This is the heat supplied. Okay. Here you will get turbine work, and this is where the compressor work is consumed. Okay. So I want to find the pressure ratio which gives me the maximum work output from this gas turbine power plant. So for that, I write first the expression of turbine work and the expression for compressor work. You know that the turbine work would be equal to enthalpy difference H2 minus H3 minus H4, which is Cp T3 minus T4. Similarly, the compressor work would be the enthalpy difference in the process 2 to 1, which is H2 minus H1, which is again Cp T2 minus T1. So now it is all mathematics. What I do is I write an expression of net work. Net work is turbine work minus compressor work, which is Cp T3 minus T4 minus Cp T2 minus T1. Okay. Now what we want is the maximum work, and you know that to get a maxima, or when there is a maximum point, at any maximum point the slope is 0, okay, with respect to the pressure ratio. So when you get this, if you go and solve this, equate it to 0, right, you get a maxima. But for that, I need to write this expression of network in terms of pressure ratio RP. So what I do now is, if I rewrite this expression of network in terms of pressure ratio, I do this mathematical jugglery. So I take T3 outside, I get in the bracket 1 minus T4 by T3. I take T1 outside, I get T2 by T1 minus 1. Okay, I'm just rewriting this expressions, rewriting this. Okay, now we all know that T2 by T1 is equal to P2 by P1 raised to gamma minus 1 by gamma, or Rp raised to gamma minus 1 by gamma. Okay, so this I'm going to put it over here. Similarly, I know that T3 by T4 is equal to P3 by P4 raised to gamma minus 1 by gamma, or Rp gamma minus 1 by gamma, or T4 by T3 would be a reciprocal of this, 1 upon Rp gamma minus 1 by gamma. So I'm going to put this here. Okay, so just substituting this now in terms of what I'm doing is I'm getting the expression of W net in terms of Rp. Why? Because I want to find the optimum pressure ratio, and I need to solve this differentiation. Okay, so now I get an expression of W net. So W net now is Cp T3 1 minus 1 upon Rp raised to gamma minus 1 by gamma, Rp gamma minus 1 by gamma, minus Cp T1 now it is Rp gamma minus 1 by gamma minus 1. Okay, so what I have done is I am just writing the expression of W net in terms of Rp. Okay, why is that I'm doing so? I'm doing this because I want to now differentiate this expression with respect to Rp, right? So for that, if I take this as dW net upon d Rp equal to 0, right? So what I get is dW net upon drp is equal to Cp T3 into 1 minus Rp raised to minus x. Now what is this minus x? Okay, I am basically trying to simplify this. So this expression of gamma minus 1 by gamma, I am putting it as x. Okay, so this W net will be CPT3 1 minus 1 upon Rp raised to x. Okay, why I am doing this? I am doing this to simplify my differentiation. Okay, you must have done this kind of tricks in your calculus. Okay, so this is the expression I am going to differentiate. Okay, and equate to 0. Why I'm equating it to 0? Because you know that in order to get the maximum, because this is mathematically speaking, if you want to get this point, this is a maxima, okay, this point, then you know that this point the slope is 0. Slope is 0. So that is what this means. Okay, this is the meaning of this, right? So I need to differentiate this d by drp, okay, cpt3 1 minus rp raised to x, I have written it as rp raised to minus x, minus cp t1 rp raised to x minus 1. Okay, this I am going to differentiate with respect to rp. Right, now if you differentiate this with respect to rp, what you will get is, you will get the cpt3 remains, differentiation of this is 0, right, and differentiation of this is minus x, differentiation of this is minus x, rp raised to minus x minus 1. Okay, and differentiation of this is cpt3 t1, and differentiation of this is x into rp raised to x minus 1, and differentiation of this is 0. Okay, so this becomes my expression. This becomes my expression of differentiation. Okay, so dw net upon so differentiation of w net with respect to rp is this. Okay, so this, if I solve this further, I get it as cp t3, this minus minus becomes plus, so x raised to rp raised to minus x minus 1, and this is minus cp, okay, yeah, here the bracket is there is another bracket here, minus cp t1 x raised to rp x minus 1. Okay, so what you have is, if you differentiate it properly, what you have is differentiation of work net with respect to rp. You can write down like this as cp, no need of brackets, cpt3 into x into rp raised to minus x minus 1 minus cpt1 into x rp x minus 1. Okay, you please do the differentiation and check, make sure that you get this value. Okay, now the important part is that we need a maxima. Okay, and for a maxima, as I mentioned here, for a maxima, that is maximum work output, the slope is 0. So what I do is, in this expression, I substitute this value as 0. Why I put it as 0? Because I want maximum work output. So 0 is equal to cpt3 into x into rp raised to minus x minus 1 minus cpt1 into x rp raised to x minus 1. So you see this cp terms would cancel off, this x would cancel off, and what we will be left with is, solve this for yourself and check. You'll be left with is T3 upon, this app is creating some problem, but it doesn't matter. Let me just rub this and write again. Okay, so now I use black. So what you get is T3 upon T1, okay, because this is 0 over here, you just substitute and do some mathematical tricks. You'll get T3 upon T1 is equal to RP raised to this, I solve, you'll get x minus 1 plus x plus 1. Okay, so you'll get T3 by T1 is equal to Rp raised to 2x, or Rp is equal to T3 by T1 raised to 1 by 2x. Okay, but what is x? X we had substituted for gamma minus 1 by gamma. So your optimum, this is optimum pressure ratio for maximum work. So optimum pressure ratio for maximum work would be now T3 by T1 raised to 1 upon 2 raised to gamma minus 1 by gamma. Rewriting this, what I get is the following: Rp okay, so again the same problem. Okay, so Rp is equal to T3 upon T1 raised to gamma upon 2 gamma minus 1. Okay, so this is the required expression which I was talking about. Okay, what is this expression? This is the expression for optimum pressure ratio. Optimum in the sense that at this pressure ratio, we would be getting the maximum work output from the gas turbine power plant. Okay, so the maximum work output from the gas turbine power plant can be obtained at the pressure ratio which is equal to T3 by T1 raised to gamma upon 2 gamma minus 1. But what is this T3 and what is this T1? If you look at the diagram, you'll find that T3 is the maximum temperature and T1 is the minimum temperature. Okay, so T3 by T1 is the minimum temperature. So T3 by T1, I can rewrite it as, again with this limitation of this app, I will write T3 as T max upon T1 as T mean. Okay, so just rewriting this expression, what you'll have is the optimum pressure ratios formula is Rp is T max upon T mean raised to gamma upon 2 into gamma minus 1. Okay, so this expression you must remember. This expression is going to give you the optimum pressure ratio for the maximum work output from a gas turbine power plant. I hope this is clear to you.